if we were to take out x and put in a, we would have ds equals 12a times dx. And that's all we got to do here. Okay, guys, so now we're going to use the application, okay? So we're kind of incorporating example 8 with this. So 9a says the edge of a cube is measured as 10 centimeters with an error of 1%. The cube's volume is to be calculated from this measurement. Estimate the percentage error in the volume calculation. So let's use a variable. So let x be one side of a cube. In this problem, one side is measured with 10 centimeters. Well, let's find the volume. So volume with respect to x of a cube is x to the third, because it's length times width times height. Since the cube, all sides are the same. Well, let's find the derivative with respect to x. So this is the change in volume with the change in the one side. So this is 3x squared. dv represents just the change in volume, so we're going to cross multiply. So now we have 3x squared times dx. This is the change in volume with respect to x, okay? Well, since x is 10, and remember, it says here the measurement has a 1% error. Well, that means the change in x, which is the change in the measurement of one side, is going to be 1% of x. Well, 1% is 0.01 times 10. So as you can see, the measurement has an error of a 0.1 of a centimeter. So since our volume is x to the third, which has a volume of 10 to the third, which has a volume of 1,000 centimeters cubed, the change in volume that has the error is going to be 3 times, well, this is what I'm using right here, guys. 3 times x is 10, so that's square. dx, we calculated from here, so that's going to get multiplied to here. So that's all of this is going to give me 30 centimeters cubic. Okay, so the change in volume is 30 centimeters cubic, but this one says estimate the percentage error. Now, if you look back at your notes, I gave you guys a formula. The percentage, okay, the estimated formula, I gave you percent change in your formula is df over dA. Okay, now, and then times it by 100. Well, we don't have f or dA, we have dv, okay, with respect to f of a, which is your volume. So the change in volume, this is dA, I think in your formula, this is going to be a parentheses, over volume of 10. So the change in volume divided by the volume when the side is 10, and then times 100 because it's going to be percentage. Well, we have dv, which we calculated as this. So dv is 30, volume is this, so that's 1,000, and we have to multiply by 100 because we want percentage. So students, this comes out to be 3%. Okay, so the estimated percentage of error for the volume is 3%. All right, B said, suppose the Earth were a perfect sphere and we determined its radius to be 3,959 miles, so 3,959 miles, with an error of 0.1 of a mile. The Earth's surface area is to be calculated from this measurement. Estimate the percentage error in the surface area calculation. And obviously, guys, you know, I love application, and this is as real as it's gonna get, right? So anytime you guys, we human, do anything, there's always going to be some sort of an error in calculation, or an error in measurement, or just could be called a human error. So here we go. So let's start with the surface area, which is S, which is going to be 4 pi r squared for a sphere. Then we are going to try to do the derivative, okay, the change in surface with the change in radius, 8 pi times r, and if we just want the change in surface all by itself, we multiply dr to both sides, so 8 pi times r times dr. Okay, so that is that for now. Well, let's go back and check really quickly. You guys, it says we have an error of 0.1 of a mile. So dr is the change, right, in the radius. And the radius is going to be 3959 miles. So the change in surface area, we're going to use this formula, which is 8 times pi. Radius is 3959. The change in radius is 0.1. We are going to bust out my calculator. Okay, this is going to give me 9950, and then surface area, so miles square. Okay. Now it wants us again to estimate the percentage, and again we are going to use the same formula from your notes, which is df over f of a, because it wants percentage, so we will multiply this by 100. We don't have f or f of a, we do have the change in surface area with the surface area when the radius is 3959, and again multiply by 100 to get percentage. We calculated ds already, which is this number. So that's going to be 9950. Let's see, when we want to plug in s of the radius of 39, so that's going to be this formula. So hold on tight, okay? 4 times pi, 3959 square. And I'm definitely going to need a calculator. I need to multiply by 100. So with my calculator, it's going to be super tiny because you got 3959 square in the bottom. 0.00505%. So the change is really, really small. All right, guys. So that's it. Example 10 from 4.5. Estimate the volume of material in a cylindrical shell with the shell thickness being 0.5. Let's correct that to feet since these all measure in feet, okay? So with the thickness of the shell of a 0.5 or half of a foot. So what we know is based on the picture, we know the height, okay, is 21 feet. We are given the diameter is 10 feet, which tells me the radius is going to be 5 feet. The change, the shell thickness, as you can see, this one's just shell thickness of half a foot. So that's really the change in radius is going to be 0.5 of a foot. Okay, so half of a foot. So if you see the thickness of it, so what's happening is the shell thickness is really what's happening here, right? So this is the shell, and that's going to be half of a foot. So that's the change in derivative. So question A says, estimate the volume. Well, what we want to do is write the volume formula down. Volume equals to pi r squared times h. The height is fixed because it gave us the height of 21 feet. Okay. So next step we want to do is we want to find the change in volume with respect to the variable, which is r, since the height is fixed. So what that's going to do is we want to do the derivative, 2 pi r times h. Well, we have to, this is estimate the volume. So we from here go into just solve for d of v, which is 2 pi r times h times dr. Well, let's plug all the stuff that we have in. 2 pi, radius, we know is 5. The height is fixed as 21, and dr is 0.5. Using, if you don't have a calculator, I will always take the exact answer, which is 105 pi feet cubic. Okay. Now, if you have a calculator and you want to punch that out, I'm okay with that too. It's 329.9 cubic feet. So I will accept either answer. So these type of questions, what you really want to know is, okay, they give all of these numbers are given to me. Do I know what they represent? Okay, so that's really what you want to be mindful of. So here's B. Estimate the volume of material in a cylindrical shell with the shell thickness now being 1 inch, and they give you a new height, a new shape. The new height is 30 inches, and the radius is 6 inches. So same thing, it says estimate the volume. So the first thing you want to do is write down the volume formula. Volume is pi r squared times h. And it says estimate the volume. That means you're going to have to find the change in volume. So we want to do the derivative of volume with respect to radius. Remember, since height is given to us, the height is a fixed value, so we don't have to worry about the height. So similarly, the derivative is 2 pi r times h. Then because it says estimate the volume, we are going to solve for dV. So that's 2 pi times r times h times dr. Let's plug in everything we have. So dV is 2 pi, radius is given to you as 6 inches. Then the height is given to you as 30. The change in dr, which is the thickness of the shell, is 1. So if you don't have a calculator, I would just take it as 360 pi inches cubic and leave it just like that. It's just fine. Okay, and that's as easy as it is to find the change in volume. The height and the radius of a right circular cylinder are equal. So the cylinder's volume, is given to us as pi times h to the cube. The volume is to be calculated with an error of no more. Whoa, that's my phone. Ha! That's my favorite song. Okay. Of no more than 1% of its true value. So let's spell that out. An error, okay, so the volume is to be calculated with an error of no more than 1% of the true value. Find approximately the greatest error that can be tolerated in the measure of h, and give it to me as a percentage. So earlier, as you remember, we were looking for the percentage of the change in radius, or we were looking for dr, or we were looking for ds, or not ds, I'm sorry, dx, because it was the change on the side. We're talking about a cube. Now we're kind of going backwards. I'm giving you the change in the volume, which means that's ds, okay? The change in volume, it says here. But remember that when you are talking about error, it can be bigger or it can be smaller. So we are going to talk about absolute value. The change in the volume cannot be more than 1% of the true value. True value of what? True value of the volume, obviously, because we're talking about the volume. So if it's talking about no more than 1%, so technically I can have 1%, just not more than that. So that's why it's an equal sign there. So guess what? We're going to have to find the derivative. So let's use your volume equation. Find ds with respect to h. So that's going to be 3 pi h squared. Let's find ds. ds is 3 pi h squared times dh. That's what ds is. Now we're going to take it and we're going to plug it in here. Well, ds, I know ds. ds, let's substitute it in. And remember, I'm using an absolute value, meaning that the change can go either way, in the positive direction or the negative direction. So 3 pi h squared dh. It's less than or equal to 1%. Let's convert that to decimal. So 0.01 times the volume. We have volume. Yes, ma'am. Volume. Oh, that's super fat. Volume is pi h cubed. Okay, so that's the volume. So now let's do basic math. As you know, we are trying to solve for dh, so I have to get it by itself. Now, just because I'm putting an absolute value around it, because the reason the absolute value is around it is because to represent the change can be in the negative or positive direction. Now, when you're solving for it, you don't need to worry about it. We're just going to divide both sides by 3 pi h squared. 3 pi h squared. Cancel, cancel. So dh, okay, it's going to be an absolute value just because the change, again, can be in positive or negative direction. Let's see what happens. Over here, what's happening? The h squared is going to cancel with the h squared. The pi is going to cancel with the pi. Oh, nice. Oh, I'm sorry, there's one h left. I should say that. So now I have no more than 0.01 h divided by 3. Let's multiply it by 100 to get rid of decimals, okay? So we have dh, absolute value of dh, is less than or equal to 1h over 300. I can work with that. So, as you can see, I just now need to find the percentage. To find the percentage, I just have to multiply by 100. So if I multiply by 100, the change in h cannot be, cancel out the zeros, so 1/3 of a percent of h. And what is h? H is the height, okay? So now let's spell that out. We are going to say the height should be measure with an error, which is, remember, dh is the error for height, of no more than 1/3 of a percent. Okay, so that's what all of that is. I spell that out in verbals, that way we know what I'm talking about. This is 1/3 percent. There's an h, that means it's all of the height. So math and English, okay, whenever you are interpreting it, that's what it means. Last problem of chapter 4. Okay. The surface area of the sphere is to be calculated with an error of no more than 1% of its true value. Again, this darn no more 1%. So I would need a surface area. And so that means surface area of the sphere is going to be 4 pi r squared. I'm probably going to need to do the derivative with respect to r. So let's take care of it. That's 8 pi times r. Let's solve for let's solve for ds. So ds equals 8 pi r dr. All right, let's leave it alone. Okay, so an error of no more than 1% of its true value. That means your change in surface area is no more than 1% of the surface area. That's what it means, right? So let's figure it out. ds is this guy. Let's plug it in. Absolute value, 8 pi r dr, less than or equal to 0.01. Surface area, it's right there. Let's plug that in, 4 pi r squared. Let's solve for dr. Divide both sides by 8 pi r. Divide both sides by 8 pi r. With that, we can cancel out that and that. We currently have dr left by itself. Let's cancel some things on this side. Let's see. I have 1 r left on the top. A pi and the pi will be gone. A 4 and the 8 will give me 2. So that will leave me 0.01 over 2 of the radius. Let's multiply this so I can get rid of fractions. I normally don't like, not fractions, decimals. I don't like having decimals and fraction all this together. So I'm going to multiply the top by 100. That means multiply the bottom by 100, just so that way I can have the fractions all by itself. So no more than 1 over 200 over the radius. Okay, that's what multiplication is for, the radius. But it wants it in percentage. So that's just really going to multiply this by 100. So with that, dr is going to be no more than, cancel the zeros, half of a percent. And then because of r of the actual radius of radius. Okay, so how do we spell all of that out? The radius should be, not should me, should be measure with an error, which is, remember, dr should be measured the radius should be measured with an error of no more than 0.5%, or you can even write 0.5%, or you can write 0.5% of the actual value of the radius. Okay. And that's sort of, you can probably write a better interpretation than that, but that's pretty much what it's about. So as you can see, this one, I gave you the percentage of error in either DS or DV, or sometimes if I give you area, then it'll be DA. And you're going backward to find either DR or DH, which is the height, right? The change in the height, or sometimes a side if it's talking about a cube. Remember earlier in the early examples, we've went and go the other route. So make sure you know how to do all of them. And that's it. It's an egg roll.